Hi, in this example, we're going to convert a Cartesian coordinate to polar coordinates. And the coordinate that they give us is 6, 3, and we're going to look for the coordinates between 0 to 2 pi. So we just have to recall some information, and I think then it becomes a simple problem. So I think the first piece of information we need to remember is that x squared plus y squared is equal to r squared. And this is just the definition of a generic circle, right? The second thing we need to recall is that x is equal to r cosine theta and y is equal to r sine theta. So I think we need these two pieces of information to answer the question because we're looking for the r and the theta. So since we're given the ordered pair 6, 3, which is the Cartesian coordinates of x, y, then we can go ahead and easily find r. So 1i, if we have x squared plus y squared equals r squared, then we definitely can do 6 squared plus 3 squared is equal to r squared, which is really 36 plus 9, which is r squared, which is 45, equal to r squared. And since, again, remember that the radius is distance, therefore r is always positive. So we don't really take the consideration of the negative of the square root. So r would just be the square root of 45, and simplifying this would be 3 square root 5. So that would be the first part. Okay, so the second part is using these pieces of information now that we have the ordered pair 6, 3, and that r is equal to 3 square root 5. So let's just use it for x, where x is equal to r cosine theta. So x is 6 equal to 3 square root 5, which is r, times cosine theta. And if I went ahead and isolated cosine theta, I would get 6 over 3 square root 5 equal to cosine theta. And therefore theta would be equal to inverse cosine of 2 over the square root of 5. And if I just put this in my calculator, I can go ahead and get the value for theta. Now, I just want to mention one more thing, is if we look here, all students take calculus, recall that the point 6, 3 is in the first quadrant. So the angle that we're looking for, theta, will be in the first quadrant. So it's important that we know that it's positive and we want something between 0 and pi over 2, or in other words, 0 and about 1.57. So going to the calculator, again, always make sure it's in radians if you're using radians. And we can go ahead and put the inverse of cosine of 2 divided by the square root of 5. And just move the cursor over, out, close the parenthesis, and we get 0.464. So theta is 0.464, which is definitely between 0 and pi.